On number 15, state the slope of the asymptotes. The only kind of equation that would have asymptotes is a hyperbola. Okay, before you can find the slope of them, this has to equal 1. So divide everything through by 16. Divide by 16, we get x squared over 16 minus y squared over 4 equals 1. This would have a center at 0, 0. On the x-axis, it would move out 4. On the y-axis, it would move up 2 and down 2. The asymptotes, remember, go through that rectangle. That's going to give you the template of where to put your hyperbolas. These ones, if the asymptotes are like this, I want to find the slope of the asymptotes. So how do you get from this point to that point? You would have to go up, which is positive 2, over 4. So if you reduce that, it's 1/2. You do have to reduce. Remember, since we also have one that's inverse of that, this is going to be plus or minus 1/2. So you do have to reduce if you can. Number 16, what kind of shape is that? Before you can determine what kind of shape it is, the x and y's have to be on the same side. So if you move this over, we'd have 9x squared minus y squared minus 4y equals 32. Now if you look at it, 2 squares, negative in between, has to be a hyperbola. That's the only kind of shape it could be. Number 17, if you're graphing and it's a negative in between, has to be a hyperbola. So here the center would be change and change. Anytime you're in the parentheses, you have to change the sign. So -2, -1. These have no denominator, so they're basically over 1. So here you're going to move out 1 on the right, 1 on the left, 1 up, 1 down. So this is going to be a pretty narrow hyperbola. Okay, if you draw this, your asymptotes will go through here. And since the x is positive, these are going to be side-to-side hyperbolas. We'll draw just like that.
Is that a same?
That is your graph. Side to side because the x is positive. For number 18, thank you. Write the equation that would result if the equation x squared plus y squared equals 7 is translated 2 units up and 3 units to the left. So, this starts at 0, 0. Okay? This is a circle. So, if we're translating 2 units up, 3 units to the left, my new center is -3, +2. Okay? A circle equation is always written as x minus h squared plus y minus k squared equals r squared. So we're just going to transplant this. So this is going to become h. It changes in the parentheses, so it's a +3 squared, plus y changes in the parentheses, so it's a -2 squared, equals, the radius is exactly the same, stays a 7. So that is your equation. Okay, you're just plugging into those standard form equations that I gave you all during notes. For number 19, identify what conic shape, so just what kind of shape is represented. Again, you have to have x's and y's together on the same side before you can figure this out. So 4x squared plus y squared equals 8. Now you can see that there's 2 squares, plus in between, different coefficient or denominator, so that's an ellipse. Okay, has to be an ellipse. There's no other shape that's like that. Number 20, circle what shape the following represents and then rewrite it in standard form. So since we have 2 squares plus in between different coefficients, it has to be an ellipse. Then to get it in standard form, you want to factor out the number attached to the squares.
Whenever they start off like that, are they going to be ellipses, most likely?
If it has different coefficients, both are positive, and there's 2 squares, then yes, it has to be an ellipse. Okay. Then plus, take out a 15 from the y's. Left behind is y squared plus 2y. Add 3 to the other side. Okay, to complete the square, take the middle number divided by 2 and square it. So that's -2 squared, means you're adding 4 in the parentheses. 3 times 4 means you add 12 to the opposite side. Same thing here, take the middle number divided by 2 and square it. For squaring 1, you add 1 to the inside of the parentheses. 15 times 1 means we add 15 to the opposite side. Rewrite this. This is 3 times x minus 2 squared plus 15 times y plus 1 squared equals 3 plus 12 plus 15 gives you 30. And then to get this in standard form, you need to divide all the parts by 30 because it needs to be equal to 1. So that's going to give you an equation of x minus 2 squared over 10 plus y plus 1 squared over 2 equals 1. X minus 2 squared over 10 plus y plus 1 squared over 2 equals 1. Number 21, find the center and radius. The only thing that has a center and a radius is a circle. So obviously this is a circle equation. Put your x's and y's together. So x squared plus 8x, I'm going to leave a space to complete the square, plus y squared minus 12y, again, leave a space to complete the square, equals, move the 12 over. Complete the square, take the middle number divided by 2 and square it. So we add 16. There's nothing to multiply by out front, so add 16 to the opposite side. Same thing for the y's, middle number divided by 2 and square it. That's going to add 36. Again, there's nothing that was taken out of the y's, so you're going to add 36. This gives you x plus 4 squared plus y minus 6 squared equals 12 plus 16 plus 36 gives us 64. From there, center comes from changing and changing whatever's in the parentheses. So center will be at -4, positive 6. Radius is the square root of what's left on the right side. Radius equals 8. Square root of 64 is 8. Given 4 times x plus 1 quantity squared plus 9 times y minus 3 quantity squared equals, and this is a typo, it should be equals to 36. Okay, so change that on your paper if you haven't already. To get this equal to 1, you need to divide by 36 on all the parts. Divide by 36, we're going to get x plus 1 squared over 9 plus y minus 3 squared over 4 equals 1. Center comes from changing the two parentheses, so center is -1, positive 3. Sketch this before you can really tell what the vertices are. Since this is a plus with different denominators, this is going to be an ellipse. So we start at -1 up 3. On the x-axis, so side to side, we move over 3. 1, 2, 3. 3 left and 3 right. On the y-axis, so up and down, we move up 2 and down 2. Make sure you remember to move 2 from the center, not from 0, 0. This is an ellipse, so attach these with an elliptical shape. Okay, then here, the vertices are not the positive ones, but on an ellipse, the vertices are the ones that are farther apart. So this is the major axis because it's a bigger axis, it's a bigger distance. So these are your vertices. This vertex is at 2, 3. So one of them is 2, 3. If you count this over here, it's -4, 3. Okay, so 2, 3, and -4, 3. And then the last one, state the coordinates of the vertices in sketch. This is also going to be a hyperbola because it has a negative in between. The center here, remember, the y is second. So your center would be at +7, -2. +7, -2. So over 7, down 2. Okay. On the y-axis, so that means up and down, you're going to move 5. So up 5, down 5. On the x-axis, you're going to move 4. So over 4 to the right and 4 to the left. This is a hyperbola, so make your rectangle to be able to draw your asymptotes through the middle and the edges. And the vertices are going to be on the y's because y is positive. So this is one hyperbola, there's the other. Your vertices are these middle points. So if you label that, that should be 7, 3 and 7, -7. So your vertices are 7, 3 and 7, -7. Okay, this didn't have a room to sketch it, but you can draw your own graph if you need to.